stuff. Hello, everybody. Welcome back to PyData Global. This next talk in the general track is practical techniques for polished visuals with Plotnine, data visualization library. And giving this talk is Nicola Rennie, and Nicola is from the Center for Health Informatics in Lancaster Medical School. So, just a quick background to the talk, and I will let you take it away. Plotnine is a Python library that implements the grammar of graphics, enabling users to create complex layered plots. This talk covers techniques for customizing your plots using time series data as an example and highlights how Plotnine integrates with matplotlib, allowing you to enhance your data visualizations for better storytelling. So we'll leave the Q&As till the end, and I will just talk about how to do Q&As at the end, but also we have the chat functionality. Nicola, I'll hand it over to you.
Perfect. Thank you very much for the introduction, Kevin. So yeah, I'm going to be talking about basically how to create more effective and more interesting visualizations when you're using Plotnine. So to give a sort of very brief introduction to myself and my background. So my background is in statistics and operational research. And I've also sort of worked in data science consultancy for a few years before I returned to academia. So I'm now a lecturer in health data science based in Lancaster Medical School in the UK. And I'm particularly interested in data visualization and thinking about how do we use visualization to communicate sort of complex quantitative information in an accessible way. And I'm particularly interested in how we use open source software to do that to make sure it's as reproducible as possible. So, what's this talk about? Essentially, what this talk is about is how I made this chart. Okay, so what we're going to do is we're going to walk through the process of I have a data set to I've made a sort of basic looking chart to I've made a really good looking chart. So, what I'm going to start with is a brief introduction to what Plotnine is. So don't worry if you have never used of or heard of Plotnine before. It's essentially a data visualization library, and it brings what's called the grammar of graphics to Python. So if you're an R user, or even if you're just a little bit familiar with R, you've probably heard of ggplot2, and it's essentially a sort of port of ggplot2 in R to Plotnine in Python. So if you are familiar with ggplot2, when we're going through some of the code, you'll notice that the syntax and to some extent the philosophy of the library is very similar. So how does Plotnine actually work? So the idea of the grammar of graphics and the idea of Plotnine is that plots are composed of different layers. Okay, so you might have a layer for the background of your plot with some grid lines, and then you might have a layer for some, let's say, points if you're making a scatter plot, and then you'll have another layer for, let's say, the title or the subtitle. And so you can edit different layers of your chart. And the way that Plotnine works is that you start with a data frame, and what you're doing is you're mapping columns of your data frames to different components or properties of your chart. So you might say, I want this column on the x-axis, I want this column on the y-axis, and I want this column over here to the values in that column to determine the color of the points. So it's all about sort of specifying what is it that you want to plot. Okay, I want a scatter plot of this column X against this column Y, rather than sort of getting bogged down in the details of how do you actually draw it. So let's start with building an area chart. Of course, if we are thinking about data visualization, we need to start with some data. So for the example I'm going to go through today, we're going to be using data from the Carbon Majors database, which is looking at historical production data for sort of oil, gas, coal, etc. So it's freely available to download and use, and it goes back to I think pre-1900s. It's a reasonably big data set, so it has sort of just over 12,000 rows, So it has information, so it's annual data, so information on the year, what the product is, how much of the product was made in that given year, what units it's measured in, and the total emissions. So for this visualization, we're going to keep it reasonably simple. And we're just going to look at the total amount of coal produced per year since 1900, and we're going to break it down by type of coal. So I'm not going to dive very much into the data wrangling because that's not what this talk is about. So you will essentially in the talk just have to believe me that this is what the data looks like. So we have 3 columns that we're interested in by the end of our data wrangling. So we have the year, the coal type in the commodity column, and then N is the number of millions of tons. All of the data wrangling code is available online in the blog post linked at the bottom there if you do want to go through it and sort of play with the data yourself a little bit. So in addition to the sort of raw data, we're also going to create some summaries of data. So we're going to be adding annotations to our plot. And wherever possible, we want to try and make these data-driven annotations. So if you're trying to sort of place or create the text for your annotations based on the data, it makes it more reproducible. And it also makes it easier if your data gets updated and you want to update the plot. You don't have to manually go and recreate all of your different annotations. If you do it in a data-driven way and write the code that creates the annotations, it'll update automatically. So we're going to add an annotation that identifies in what year does the number of millions of tons exceed 100 for the first time. So we do a little bit more data wrangling, calculate how many millions of tons there are per year, and figure out when was the first one. We're also going to take our customization a stage further, and rather than using the default sort of X and Y axes, we're going to create our own. Okay? So I'm going to create some data to create those custom X-axis labels. So essentially, where are they going to be positioned? And I'm going to do something similar for the Y-axis data. Before we sort of jump into creating our first plot, I also want to talk a little bit about colors and fonts. So one thing that I've started doing and that I found to be really useful is defining variables for colors and fonts. Right? So I'm going to color in the area chart, I'm going to color based on different coal type. So I'm going to create a color palette with 6 colors in it and save that as a variable called color palette. And then I'm also going to define variables for the background color and the text color. So I want to point out that this is not an essential step for creating plots with Plotnine, but it is a useful one. So you can just use the default colors if you want. And I think, as with most plotting software, the default colors look fine. But if you want them to look good, you probably have to specify some other colors. You can also just pass these values in manually directly to the plotting code. But if you decide at the last minute you want to change your colors, then if you change the variable, it will update the whole thing for you, in contrast to sort of having to manually go through and update all the individual places where you've used the colors. So you can do something very similar for fonts as you do with colors and create a variable for a particular font family that you want to use. I quite often have 2, so one for the title and then one for all of the other text in the chart. Here I'm just going to define 1, and it is just going to be the default font. But again, it makes it easier to change later on. As with colors and fonts, I'm also going to create some variables to store the title and subtitle text. Okay? So kind of straightforward, write a title and write a subtitle as some character strings. Here, I'm also going to use the text wrap package. So this is a really useful package if you have very long strings of text, like we do for the subtitle here. So by default, these are just going to run off the end of the page, and you'll sort of only get the first half of the first sentence on your chart. The text wrap package lets you sort of specify how wide your text should be, and then wraps it so that it fits within the area of your chart. So this is really useful if you do have big chunks of text in your charts. So now we're actually finally ready to start plotting. So the first thing we do is import the Plotnine library. I import it, as do many others, as GG, sort of in recognition of the original ggplot2. And then we create our sort of initial plot object. So when we're building charts with Plotnine, we always start with the ggplot function, and it has 2 arguments. So the first argument is super easy. Okay, that's just the data set. So what data has the columns in it that you want to be plotting. We then have the second argument, which is the aesthetic mapping. Okay, so this is where you're specifying what columns in your data map to which different elements of the chart. Okay, so here we're putting the year column on the x-axis and the n column on the y-axis. And you'll notice here that they are wrapped inside this AES function, okay? And that's because we are mapping from the data to the chart. Okay, so AES short for aesthetic mapping. One final thing to point out about this, and it's a really nice feature of Plotnine, is that you can save plots as variables. Okay, so I'm going to save this initial basic plot as a variable p for plot. And because you can save it as a variable, it means you can iteratively add layers to your plot. So that initial line of code with the ggplot function creates this. Okay? And this might or might not be how you would expect this chart to look. Okay? It's essentially an empty chart. It does have this sort of x and y axes pre-populated with the range of values that are in those columns, and it's given it some axis titles, but there's nothing actually in the chart itself. And the reason for that is because we need to actually specify what kind of chart we want. You know, what is it that you want to draw on the chart? And the way you do that in Plotnine is with something called geom functions. Okay, so geom short for geometry. So what type of geometry do you want to draw? Do you want to draw a line or point? So we're going to start by creating our custom axes. So we're going to draw some vertical lines for our x-axis. So we want to add some line segments. And so we're adding geom segment. Okay. We do something very similar for the y-axis, and here we're adding labels as well. So we're adding text labels, so we're using geom text. And we can pass in to the color and family arguments are variables that we saved for the text color and the sort of text font family as well. One other thing that you'll notice here is that I have specified a different data and aesthetic mapping. So the nice thing about Plotnine is that you can change what data you're using or what the default mapping is for each individual part of your chart if you want to. Whatever you pass into the ggplot function is the default, but if you want to override it for a particular layer, you can. Okay. So when we draw on our segments, okay, so we have some dashed vertical lines for our new x-axis with some labels. And then we also have some labels on the sort of right-hand side essentially as an alternative to the default y-axis. So there's still a couple of things we need to fix with this chart. So one thing is that the annotated text on the right-hand side is getting cut off a little bit. You can't quite see the full annotation, so we maybe need to add a little bit of spacing. We also need to get rid of the sort of duplicate axes. So we need to get rid of the original ones. And of course, the obvious thing is, well, we need to actually draw an area chart. So what we're going to do is we're going to add our annotations. Okay? So I want to add different elements of an annotation. So I want to add some strong vertical lines, and I'm going to, again, do that with the segment geometry to highlight sort of which year in the data I'm adding the annotation for. And I'm also going to add some text with the words for the annotation. Okay? So here I am using GG annotate rather than a sort of geom function. So the reason that I'm doing that is because these annotations essentially relate to a single data point. Okay? So we tend to use geom functions where we're mapping columns of the data to our plot. But if you only really want to add one little thing, you don't want to create a whole data frame just for one data point, so you can use the annotate function instead. And this creates some vertical lines, and it adds our annotations. Okay, so here I've sort of added 5 annotations. So you have the 2 vertical lines. You then have the 2 sort of titles, which are in bold text. Okay, so if I go back a little bit here, you can see in a couple of the annotations, I can specify the font weight as being bold. And then it adds an additional annotation sort of underneath the first one to give a little bit more information. And then finally, we actually add our area chart with geom area. And again, we're going to specify a slightly different aesthetic mapping, okay, and say that fill is equal to the commodity column. Okay. So when you're trying to use color in Plotnine, there are 2 variables, fill and color, that control the color. Color is the outline color, whereas fill is sort of the fill color, if you like. So we want the sort of area of the chart to be colored based on the values in the commodity column. There will be a default color palette added. You can change that using scale functions. So we can use scale fill manual to pass in the color palette variable we defined earlier into our scale for colors. So I'll use the hex codes in that color palette variable for the color scale. Okay, and you can use similar features to change the limits of the x and y axes. Within Plotnine, there are arguments for adding a title and subtitle. I've chosen here to just add them as annotations rather than sort of proper title and subtitles, because that will let you position the text within the plot area, which saves a little bit of space just because of the way the data actually looks. And so that gives us this initial chart. Okay, so we're almost there. Okay, we still have to sort of edit the extra sort of duplicate axes. The other thing we want to do here is sort of use a slightly better legend. So what we're going to do is we're going to add some colored text instead of the sort of colored boxes. And we'll use the colored text to identify the different categories. So in Plotnine, when we talk about sort of theme elements, we essentially mean all of the background elements. So anything that's not really related to the data. So stuff like the background color or the sort of width of the grid lines or the size of the title text, for example, that's not based on the data, that's background elements. So we use theme functions to edit that. So the theme void function is a very sort of, I guess, harsh theme. And that just removes all plot elements that aren't based on the data. So it removes all of the grid lines, the axes, everything. And that's what we want to do here because we've already sort of made our own. You can use a sort of base theme like theme void or one of the other built-in themes, and then edit more individual elements of it. Okay, so if we want to make sure that there's no legend, we can set legend position to none. We can also edit the background color, again, passing in the variable we defined earlier for our background color into those arguments. So you'll notice here there are two arguments that control the background color. One is the plot background color and one is a panel background. So plot is sort of the area outside of your chart, whereas panel is the sort of area within the chart. Okay? So the white space is the plot background and the gray area in the default theme is the panel background. So this is what our chart looks like after we've done that editing of the theme. Okay, and that's reasonably few lines of code to go sort of from this to this, and it just looks much cleaner and much more sort of minimal. The last thing we need to do is figure out a way of adding that colored text as an annotation. Now, unfortunately, there isn't a sort of built-in way within Plotnine to do colored text within a sentence, but there are other libraries that allow you to write colored text within a sentence. And this is where we're going to sort of exploit a key feature of Plotnine. So Plotnine is sort of built on top of matplotlib. Some people might see that as a downside in that it's not bringing some brand new graphics engine, but actually you can exploit that fact. And anything that works with matplotlib, you can probably get it to work with Plotnine. So what we're going to be doing is we're going to be using the highlight text library. Okay? And it's really nice. It's a really nice way to make sort of fancier and nicer looking annotations in a way that's actually quite easy. And it essentially gives you a way to specify different properties of fonts for substrings of text. So if there's a particular word within a sentence that you want to be in sort of bold red text, you can change just that word and just the sort of properties of that word within it. So you can do things like change the color, change the background color, different font size, different weight, different styles. And the way you do that is with a combination of sort of specifying within curly brackets. So you within arrows, you specify what the text is that you want to be colored. And then within the curly brackets, you're specifying what the properties are. Okay? So if I wanted to write a sentence that had the words colored text written in red, this is how I would do it. So we can sort of take that simple example a little bit further. So we might want to add an annotation that uses the hex codes from our color palette and changes the different col categories to those different colors. The other thing I quite often do is add a caption where you give the source of the data and the sort of source of the graphic and highlight the words data and graphic in bold text. Now to actually add these highlight text annotations to our Plotnine plot, we first need to sort of convert our Plotnine plot to a matplotlib object. Okay, so we have our Plotnine plot is saved as p. So p.draw creates our matplotlib object. Okay. And then we can add our highlight text annotations. Okay, so we use the ax text function to say, okay, I want to add my annotated highlight text at these coordinates with this label and with this default color and font for all of the bits I haven't already specified. And then you're just using plot.show as you normally would for matplotlib. And you get this sort of annotated chart. Okay, so you can see that in the annotation underneath col types, we have all those different colors of text that match up with the different colors in the chart. So just to sort of finish off and summarize this, basically Plotnine lets you build plots one layer at a time. And that I think that's a really nice way of doing it, is sort of just concentrating on one aspect of your plot at a time and getting yourself happy with that before you move on to the next one. I think the syntax is it's fairly intuitive, even though it might initially look a little bit complicated. Okay? Functions are generally named very well. If you want to draw a point, it's geom point, for example. Customizing plots, whether you're using Plotnine or whether you're using a different library or a different programming language altogether, it always takes a little bit of work to customize plots. But I really do think it's worth it to make better data visualizations. And when you are using Plotnine, you can use libraries that work with matplotlib to gain extra features. So you're not limited to just those core functions within Plotnine itself. So I will just end by sharing some resources. Okay? These slides are available online, and the code for the chart itself is also online as well. Plotnine documentation and the Plotnine gallery are both excellent as well if you're ever looking for inspiration to go and create your own Plotnine graphics. But otherwise, thank you very much for coming along.
Great stuff. Thank you very much, Nicola. So actually, there are some questions there in the chat. There is a menu bar there on the right hand side, and third down is the Q&A. Just actually the first question here comes from Tolu Shikoni. I hope I pronounced that correctly. How does Plot9 differ or compare to Plotly, Plotly Express, Matplotlib, etc.?
That's a very good question. So I think in my head there's for slightly different purposes thinking about Plotly versus Plotnine. So I think Plotnine is really good for static graphics. So if you're making something that might end up in print or a sort of journal article or a static plot on a website, whereas Plotly is kind of more for your interactive graphics. And I think it depends what type of chart you're creating, whether that's which one's the most appropriate there. In terms of matplotlib, I hope I covered that a little bit at the end. If you're using Plotnine, you can use the matplotlib features. Um, I guess my thoughts on visualization libraries is that as long as you can draw, lines, points, rectangles, you can make any chart you want to in some way. It's just how easy it is to get there.
And we had just a follow-up question on that. How about comparison to Seaborn?
Um, Yeah, another very good question. I do quite like Seaborn, and when I'm not using Plotnine, I do tend to use Seaborn as my graphics of choice. Um, I think I would say sort of personal preference, and I
Hmm.
guess a little bit on what your background is. I am hoping that the Plotnine sort of community grows even more, and you get some more new functions for sort of custom charts.
Yeah.
Um, I think as well with Plotnine is that data visualization with ggplot2 and R, that's a very big community. So there are lots of examples of using the grammar
Okay.
of graphics there.
I was going to ask that about your point of view of that. So my understanding is that the ggplot, which is the R programming language for data visualization, and Plot9, well, they are actually sort of the cousins of each other. Isn't that correct?
Yeah,
A-
essentially, yeah.
And that the no, just actually the syntax is very important. Now you referenced that there's a very unusual Plot9 syntax. Would it be fair to say that this syntax is more to do with the grammar of graphics as a sort of way of converting, basically making good data visualizations?
Yeah, yeah. So it is naturally sort of similar to the R one, but it's not, because it's similar to R, it's because they're both sort of based on the grammar of graphics. So it's thinking about how do you take elements of data frame and how do you map that to elements of a chart. So it is very much thinking about what columns of your data are you using, and then what different elements or what different geometries
Mm.
is it that you're mapping. So it might feel slightly different, particularly if you are kind of used to things like matplotlib, where I guess it's probably quicker to get to a basic plot with matplotlib. You can just sort
Hmm.
of plot it. But in order to get that sort of customization, I think that is a little bit easier
Okay.
with Plotnine.
Good stuff. Just one follow-up question there. Again, I was wondering how Plotnine differed from Altair, which is another declarative style plotting library.
It isn't something I've actually used. It's something that's sort of on my list of things to go and play with. So I don't have an answer to that right now,
Okay,
but I might have an answer in the
good
next few
stuff.
months.
Now, just actually, I know that these sort of data visualizations will be very useful, particularly if somebody was like, let's say, more working in the civil service or like environmental something, something environmental or something where graphics are, very important. Good quality graphics. Just actually, how would you recommend learning more about Plot9?
Um, so there's this year was the first iteration of the sort of Plot9 contest by
Okay.
Posit, and there are some tutorials in the works of taking you through the process of how to make all the different charts that were submitted. The Plotnine gallery is really good. It's got some really nice sort of reproducible examples of plots. So I always think that's quite a nice place to start is, take the code that makes this other chart and then go and sort of play with it and edit it a little bit. That's probably where I would start.
And like the syntax in R and plot, or sorry, ggplot, R's ggplot and plot9 is sort of similar enough that you might be able to sort of extract one set of ideas and just do the necessary translations.
Yeah,
Uh,
definitely. It's sort of
Okay, that's good.
yeah, yeah.
So yeah, you can see. I mean, not it won't probably not be 100%, but you'll be able to sort of
Yeah, it's
tap
not
that
quite
resource.
100%. It's something like there'll be a dot instead of an
Yeah,
underscore,
that's right. Yeah,
and
so
arguments might be slightly differently named, but
yeah, yeah,
yeah,
yeah, yeah,
it's
yeah.
it's
But
fairly
yeah.
straightforward.
So that the ggplot, the R language ggplot has been around for about 10 years, so it has a wealth of code samples around the place. Where plot9 is more recent. Is that correct?
Yeah, it's been around for a little while, but yes, I think ggplot2 is actually it's coming up on 18
Oh,
years old now.
right.
It's definitely been here for a long time. And yeah, Plot9 has sort of taken off in the last couple of years.
Okay.
But I imagine if I'm sure you could send some ggplot2 code to ChatGPT and it would spit out some some beautiful Plot9 code doing the
Good
same
stuff.
thing.
I'll finish with one last question there. Just actually a little bit about yourself. Because of the time constraints, I didn't really go into a full biography about yourself. But you could just actually just sort of, if you want, just tell us a bit more about yourself as a closing question there.
Yeah, so I think as I kind of mentioned at the start, I'm particularly interested in visualization and how we use it. And I've been doing quite a lot of work with the Royal Statistical Society to develop some data visualization guidance for people who are creating plots or particularly for RSS publications. So you kind of mentioned a little bit about if you're working in the civil service and you wanted some examples of how do we implement almost like a style guide of sort of
Hmm.
what types of charts you create, what colors do you use. It's sort of pulling together different sources of information and sort of building resources um, for visualization for statisticians mainly.
Good stuff. I think a lot of people underestimate how big a deal this is in the public sector, and that the public sector is a very substantial uh, place of work actually and place of like activity for data science. So I'll leave it there. So just actually again on the main page there we have your socials. If you want to follow Nicola and on LinkedIn and Blue Sky, there were all the socials there. So and great stuff. Okay, folks, I think we'll leave it there. And thank you for that. And I'm going to end the session now. So thank you all. Hopefully, you'll all be able to hang out on Discord and chat with each other and find each other and maybe reach out to both myself and Nicola. Thank you very much. We'll leave it there. Thank you
Thank
very much,
you.
folks.